Tangents parallel or perpendicular to a given line. The slope of the line L, ax plus by plus c is equal to 0, is minus a over b. So to get the slope of this line, we take the coefficient of x, that becomes the numerator, the coefficient of b, that becomes the denominator, and we stick a minus in front. If there's already a minus there, then it's a minus minus, which becomes a plus. And so we can say that any line that is parallel to L has the equation of the form ax plus by plus k is equal to 0. So basically, the coefficients of x and y will be the same, but the plus c, the constant at the end, will be different because it has the same slope as L. A line perpendicular to L has a slope of positive b over a. So basically, we take the reciprocal of this, so we turn it upside down and we change the sign. So if it's minus, it becomes positive. If it's positive, it becomes minus. And so its equation can be written in the form of minus bx plus ay plus k is equal to 0, or bx minus ay plus k is equal to 0. So basically what we do is we swap the x and y values and we change the signs. So the question says, find the equations of the two tangents to the circle x squared plus y squared minus 2x minus 8y plus 4 is equal to 0, which are perpendicular, so meet at right angles, 90-degree angles, to the line 3x plus 2y equals 11. So, a line perpendicular to 3x plus 2y is equal to 11 can be written as 2x minus 3y plus k is equal to 0. So, what I did here was I swapped around the coefficients of x and y. So 3x becomes 2x and 2y becomes 3y. And then I changed the sign in between. So the plus becomes a minus. And then I added in the plus k and I let that be equal to 0. So I have a line perpendicular to the given line written in the form of 2x minus 3y plus k is equal to 0. So I let the equation of the perpendicular tangent be 2x minus 3y plus k is equal to 0. So this is the equation of the perpendicular tangent to the given line. The circle has a centre of 1, 4. I got the 1, 4 from the coefficients of x and y in the given circle. So the coefficient of x was minus 2, half of that is minus 1, changes sign, we get plus 1. So that's my x value. Coefficient of y was minus 8, half that we get minus 4, changes the sign, we get positive 4. So my y value is 4. So the circle has the centre 1, 4. Next, I need to find the radius. So I'm going to use my formula, the square root of g squared plus f squared minus c. So the g is 1, so 1 squared is 1. The f is 4, so 4 squared is 16. And then we have minus c, and we had plus 4 in our equation, so that becomes minus 4. So the square root of 1 plus 16 minus 4 is the square root of 13. So the radius is root 13. So the line 2x minus 3y plus k is equal to 0 is a tangent to this circle. Thus, the perpendicular distance is going to be equal to the radius. So we're going to use our perpendicular distance formula, which is the distance from a point to a line formula, which is the modulus of ax1 plus by1 plus c, all divided by the square root of a squared plus b squared. So we get the a, b and c from our linear equation and the x1 and the y1 from the point. So we need to decide what the a, b and c is. So we go to our line that's tangent to the circle and we need to label it a, b and c. So we get a is 2, b is minus 3, c is k. And then we take our point 1, 4 and we label it x1, y1. So the 1 is x1 and the 4 is y1. So the perpendicular distance is going to be equal to the radius. So we have to substitute into our perpendicular distance formula and let it be equal to the radius, which we know is root 13. So I've labelled my a, b, c and my x1, y1. So I just substitute into the formula. So I get the modulus of 2 times 1 minus 3 times 4 plus k, all divided by the square root of 2 squared plus minus 3 squared. And I let this equal to root 13 because we got the radius equal to root 13. So next I just have to simplify. So 2 times 1 is 2, minus 3 times 4 is minus 12. So 2 minus 12 is going to be minus 10. So I get minus 10 plus k. Next, I'm going to do the denominator. So 2 squared is 4, minus 3 squared is 9, and 4 plus 9 is 13. So I end up with root 13 as my denominator. So what I would do at this point is let the root 13 on the right hand side of the equal sign become root 13 over 1. And I would cross multiply and solve for k. So remember, I have the modulus of minus 10 plus k, or k minus 10 as my numerator. And that multiplied by 1 is just the modulus of k minus 10. And then remember, I have root 13 as my denominator. And root 13 times root 13 is 13. So we end up with the modulus of k minus 10 is equal to 13. So when we have the modulus symbol, we know we're going to break our sum down into two parts. So we take what's inside the modulus, which is k minus 10, and we let it equal to what's on the right hand side of the equals, which is 13. And then we take again what's inside the modulus, which is k minus 10, and we let it equal to minus 13. So whatever is on the right of the equal sign, we let it equal to the positive value and the negative value. So k minus 10 equals 13, so k is equal to 23, or k minus 10 is equal to minus 13, so k is equal to minus 3. Thus, the required tangents are 2x minus 3y plus 23 is equal to 0, and 2x minus 3y minus 3 is equal to 0.